Right, so I'm going to work through the AS mock paper. So first up, we've got the integral of 2/3 x cubed minus 6 root x plus 1. All right, first we need to just get ready to integrate. We can't integrate when we've got a root, so we need to realise that that is x to the power half. So we've got the integral 2/3 x cubed minus 6x to the half plus 1 dx. Remember, integration, increase power, and then divide by power. So our integral is going to become x to the power 4, so we've got to divide this by 4, so we can say it's 2 over 12 for now. Power here is going to go up to 3 over 2. We've got 6 divided by 3 over 2. 6 divided by 3 over 2 is the same as doing 6 times 2/3, so it's going to be 12 over 3. And then 1 will go to plus x plus c. It does want us to give it in its simplest form, so 1 over 6 x to the 4 minus 4 x to the 3 over 2 plus x plus c. So this one, we're looking to do some proof for this one. So first of all, show that this quadratic is greater than 0 for all real values of x. Now there's a few ways you can do this, but I think the best way is to combine it with a sketch. So first of all, we'll find the minimum point of this. Now you can find the minimum point with differentiation or with completing the square. So if we differentiate, we're going to get 2x minus 8. And find the minimum is when that equals 0. So 2x equals 8, so x equals 4. So the minimum point for this quadratic is at 4. We can put that back in to find the y coordinate. So 4 squared minus 8, that's a 4, plus 17. Which gets us y equals 1. So if we sketch this now, we know the minimum is at 4, 1. We know it's a positive quadratic with a 17 intercept. So we can sketch it, and we can say therefore always greater than 0. Other method we can do for this is to complete square, which is a more algebraic way of doing it. So we get x squared, or x minus 4 squared, minus 4 squared, which is minus 16, plus 17. So x minus 4 squared minus 1, so plus 1. And then we can say, looking at this, any number that you put in here, be it positive or negative, if you square it, it comes out positive. Add 1, it's always going to be positive. So any number squared is positive. Plus 1, still positive. Cool. Part 2, or part 2 for this one. If I add 3 to a number, square the sum, the result is greater than square the original number. So we need to state if this is always, sometimes, or never true. So we need to test it out, basically. Easiest way to kind of decipher this is to turn it into algebra. So we've got a number, let's call it x. We're going to add 3 to that number, square that sum, and we're saying that should always be greater than the original number x squared. So we're trying to prove whether this is sometimes, always, or never true. Now just looking at it, it's obvious that negatives and positives are going to have different results. If we chose x equals 1, we're going to get 4 squared, which is greater than 1 squared, so true. So it might be always true, or it could be sometimes true. So we're going to test and try and get something to break this. So looking at this, if we pick a negative number for x that's less than 3, this result will be negative, and it should give us the opposite. It should be able to prove that it's not always true. So we're going to try x equals minus 4. Now, minus 4 plus 3 gives us minus 1 squared. Is minus 1 squared greater than minus 4 squared? So we get 1 is greater than 16, which is not true. So the overall summary is therefore sometimes true. So basically just try 2 different versions, one that's true, one that's not true, and say it's sometimes true. Right, logs. So first bit to this is identifying 2 errors made by the student. So if we zoom in a bit, I've looked through. So first thing they should have done is use the power rule straight away, but they didn't. So we can put 1 power rule not used. So 2 log base 2 of x equals log base 2 of x squared, and that needs to be done before. Needs to be done before subtraction rule. The second error we can have, if we look closely, we get to using the definition of log. 2 cubed is x, they've said 3 squared is x, so that's also wrong. So it should be 2 to the power 3 equals x. So x equals 8, not 9. Okay, now we have to do it ourselves and find out what the result is. So we're going to do it right. We're going to make sure we don't do either of these things wrong. So first step, use the power rule. All I've done there is rewrite our root as power half. Now we can use the subtraction rule for this. So we get log base 2 x squared over x to the half. 3. We can simplify this bit here. 2 divided by, or x squared divided by x to the half, subtract those powers. So we get log base 2 of x to the power 3 over 2. Now we can change it to exponential form. So 2 cubed is this. So in other words, 8 equals x to the 3 over 2. Then we can cube root both sides and then square both sides. So cube root both sides, we get x to the half equals 2, and then square both sides to get x equals 4. Okay, next up we've got a modelling question which I didn't leave enough space for, so we've got some more paper here as well. And the trick to these is just spotting what type of pure maths they're actually asking about. So we've got this graph showing a company makes some toys. I'm told the annual profit is given by this. So P is profit. So let's write that up here. What annual profit? And then X on the x-axis. So what is X? So read. P is that. X is the selling price of the toy. So this is selling price of toy. So by labeling this, we've made our graph better and it should be easier to spot what's going on. So first bit, using the model, why is 15 not a good price for the toy? Well, I don't know, let's find out. So we put in x equals 15 into here and see what our profits are. So P equals 100 minus 6.25, 15 minus 9 squared. So let's work that out. Well, we get minus 125. So our profit for the year, if we sell our toys at £15, we lose £125,000 per year. So make a loss of 125,000. So that's not a great idea. So bad idea. Some of you got that, but you need to show it numerically. To show that you put it in and show what your loss is. Right, next bit. Given the company made a profit of more than 80,000, so we know P is greater than 80,000. Find the least price of the toy. Now you have to read carefully because P is the profit measured in thousands of pounds. So when it says here £80,000, we're going to put in P as 80 into this equation. So if I write 80 equals 100 minus 6.25 x take 9 squared. All we need to do is solve this for x to find the least selling price for this toy. Profit should be more than 80,000, so 80 should be less than our profit. So if we try to solve this, it's actually quite easy to solve as long as you don't try and expand the quadratic first. So we're going to take 100 from both sides, divide by negative 6.25 square root and add 9. So take 100 from both sides and we get minus 20 is less than minus 6.25 x take 9 squared. Divide by 6.25. It's a negative, so we're going to divide by a negative, in which case we need to flip this sign over. So 20 over 6.25 should be greater than x minus 9 squared. So we can just calculate now. 20 divided by 6.25, 16 over 5. If we square root that, we're going to get about 1.7. So let's say 1.78. Just give us a thing. No, 1.79. Let's round it up. It's greater than x minus 9. Now this could be plus or negative because we've square rooted. So my two values for x is either x is going to be less than 10.7 or 10.8, I guess. What was it on it to? 10.7 or 10.8, let's say. Or x is going to be less than 7.22. So the least selling price for the toy has got to be this one because it gives us a lesser amount. So 7.22 should be your answer there. If you rounded it badly, you'll get 7.21, which would be incorrect. So you've got to be careful with your choice for that one. Yeah, £7.82. And we also put pound sign in there because we are dealing with pounds, because you do get a mark for that as well. Okay, next bit, find the maximum possible annual profit. So we want to find the maximum point, and if you remember from calculus, maximum is when dy by dx equals 0. So we need to differentiate our p equation. Okay, so our maximum is going to be when dp by dx is equal to 0. So we need to differentiate our p equation. Remember, p is 100 minus 6.25 x minus 9 squared. Actually, we don't even need to do that because we got a quadratic. We can find the maximum point by completing the square. And look, it's already been completed. So the maximum profit occurs when x equals 9. So max when x equals 9, and the max value is going to be 100. So from completing the square, that's the coordinate of the maximum point or the minimum point, and that is the y coordinate of the maximum endpoint. Now we've got to be careful because x and p mean different things. So max value is p is 100, maximum occurs when x is 9. So if we look back at the question, the maximum annual profit we worked out as 100, but that's measured in thousands of pounds. So the max annual profit should be £100,000. And the selling price that maximizes the profit is our x value, so x equals 9. And x, if you look, is the selling price of the toy in pounds. It's £9. So £9 for that one and £100,000 for that one. Okay, question 5, which was all to do with trigonometry. So really, this just required that you remember the equations for area of a triangle. So we're told about this triangle. Let's do a quick sketch. So it's ABC, ABC. AB has a length of 10, AC has a length of 5, and BAC is theta. And we're told the area of the triangle is 15. So area of a triangle that isn't right angled is half AB sine C. Now, this is why they've tried to confuse you. These ABs and Cs are not these ABs and Cs. This just means two, basically, generic A, B, C. It means two sides and the angle enclosed. Two sides and the angle enclosed. So learn it as that instead. The area of a triangle is half of two side lengths times the sine of their angle. So for this, we're going to get area equals half 10 times 5 times sine of theta. We know the area is 15, so if you come down here, 15 equals half times 10 times 5 times sine theta. So we can work this out. We've basically got 10 times 5, 50, half of that, 25 times sine theta. So 15 is 25 sine theta. Divide by 15, 15 over 25 is sine theta. And we can simplify this, divide tops and bottoms by 5. So get sine theta is 3/5. Excellent, but they want us to find the two values of cos theta. So we need to go from sine theta to cos theta. A couple ways you can do this. The easiest one is using right angle triangles. So if I sketch a right angle triangle with an angle, you know sine is the opposite over the hypotenuse. So sine opposite, hypotenuse 5. Cos, however, is the adjacent over the hypotenuse. So if I find the adjacent, we can find cos of the angle without having to do any actual calculations. So we'll say 5 squared, because that's the hypotenuse, subtract 3 squared equals, say, x squared. So 25, take 9, equals x squared. So x is going to be x squared is going to be 16, so therefore x equals 4. So that side is 4, so cos of the angle is going to be 4 over 5. But I hear you say, or maybe not, two possible angles, where if we sketch cos, 4/5 is about here. There's going to be one possible angle there, and one possible angle here at minus 4/5. So cos minus 4/5 as well. So those are our two possible values of cos theta. Can't have any more because it needs to be between 0 and 180, and the next one's 270, which won't fit in a triangle. So those are our two different values we can get for cos theta. Right, find the exact length of BC. So we want to find this length here. So we're going to be using the cosine rule. Hopefully some of you spotted. If you know this bit here, you can quite easily use the cosine rule to find that. So cosine rule says a squared equals b squared plus c squared minus 2bc cos a. Now that is why they asked you to find cos of our angle in the first place, because we're going to be putting one of these values straight in there to find this length. Cool. Okay, so we're going to use this with our values. So we've got a squared, which is going to be the side we want to find. B squared, either of these to be honest, so tan, c squared 5, and 2bc cos A. Cos A is going to be one of these two values we got over here. So a squared equals 10 squared plus 5 squared minus 2 times 10 times 5 cos A. So if we work out the rest of it, and we can try it with 4/5 and with minus 4/5 and see which one makes the most sense. Cool, so if we do this, a squared equals 100 plus 25 minus 100 cos A. So we get a squared equals 125 minus 100 cos A. Okay, now we've got to think about whether it's going to be 4/5 or minus 4/5. So I guess we could just try it with both for the process of this. You might be able to think about it and work out which one it has to be, but we are told it's the longest side of the triangle. So if we do both and pick which side gives us the longest length. Actually, just looking at this, it's going to be the negative, because again, minus times a minus, positive, will make it bigger. So a squared is going to be 125 minus 100 times minus 4/5. So a squared equals 125 plus 80, I think that's going to be. Yeah. So a squared equals 205. So a equals root 205. Which is about 14, so it's bigger. If we did it with the other one real quick, 125, take away 80, root that. Yeah, so if you did it with the wrong one, you'd end up with a side length of 1.25, which is way smaller, and it is meant to be the longest side of the triangle. So it must be root 205. Okay, next one. This one went really badly for most people. So we've got a lorry driver. We've got a modelling question. It's going to be to do with differentiation, maximums, minimums, so lots of differentials. So first up, we've got cost is this equation. So the cost of a journey depends on the speed. Of course it does. Find the value of the speed or the velocity that minimises the cost. So we're basically going to find dc by dv and find which velocity gives us a minimum journey cost. So if we write it out, c equals 1,500 v plus 2 over 11v plus 60. At the moment we can't differentiate this because v is on the bottom, so we need to bring this up to the top using negative powers. So c equals 1,500 v to the minus 1 plus 2/11 v plus 60. As I said, we want to differentiate because we're trying to find a minimum. So minimum is when the gradient of this function is 0. So dc by dv is going to equal 0. So differentiate this, set it equals 0. So dc by dv is minus 1,500 v to the minus 2 plus 2 over 11. And we're going to make that 0 and solve it. Solving this looks horrible, but we can just put the v back on the bottom. So like we did here, bringing it up, we can do the same thing and bring it down. So 1,500 over v squared plus 2 over 11 equals 0. Times everything by v squared. Rearrange to get v equals. So we get v squared equals 8250. So v equals plus or minus 5 root. Let's do it exactly. Plus or minus 90.8. Cool. Yeah, I guess we'll just stay positive because it's relative, isn't it? So yeah, that's our velocity that gives us our maximum. The minimum cost of the journey is going to be the cost when you're driving at this speed. So if you put this speed back into the v equation, we'll find our cost. So c equals 1,500 over 90.8 plus 2 over 11 times 90.8 plus 60. And you get 93 pretty much on the dot, so equals 93 pounds. So it also should have meters per second. Or not even that, kilometers per hour. So units important, kilometers per hour and pound sign. There. Cool. All right, part B, prove it's a minimum. So hopefully you remember from differentiation, to prove it's a minimum, the second derivative, it even tells you the second derivative, should be a positive number if it's a minimum. So we're going to find d2c by dv squared, remembering dc by dv was, what was it again, minus 1,500, v to the minus 2 plus 2 over 11. So differentiate that again, this is going to disappear, times by the power, so we get 3,000 v to the minus 3. That's already positive. If we put in 90, which we should, 3,000 over 90.8 cubed. We get 0.004, which is positive. Just positive, but it is positive. Therefore, this is a minimum, which you need to have in your notes as well. Okay, last bit, state one limitation of the model. Let's have a read back again, see what's going on. So we've got cost of journey, driven at a steady speed, blah, blah, blah. Okay, so limitation, is it likely a lorry is going to be driven at the same speed all the way from London to Newcastle? No. So we can say unlikely the lorry will maintain a steady speed. Cool. Right, question 7. This is going to come up in the exam in one form or another. Prove using first principles, very important, the derivative of x cubed is 3x squared. So we got f of x is x cubed, and we're trying to prove that it goes to 3x squared. So if you look in the formula book, you find the differential is equal to f of x plus h minus f of x over h when h tends towards 0. So write this out, and then we're going to populate it with the things we need. So if this is f of x plus h basically means change this x into x plus h. So end up with x plus h cubed. Then we're going to put this here, h there, sort it all out. So the differential is x plus h cubed minus x cubed divided by h. Expand this using binomial if you're good, otherwise brute force it and take your time on it. Take away x cubed divided by h. So I'm good with binomial, so I know it's going to go to x cubed plus 3x squared h plus 3h squared x plus h cubed minus x cubed, don't forget that, all over h. So x cubed cancel. We can then divide everything by h, so we get 3x squared plus 3hx plus h squared. And we know h tends towards 0, so when this goes to 0, that's going to disappear, and we're going to be left with 3x squared, which is what we wanted from the beginning. Right, binomial expansion. So use the formula if you need it. We're trying to expand this thing, first of all, just the first 3 terms, and then we're going to do something that none of you can do with it afterwards. So first of all, let's just start with expanding this. So 2 minus x over 16 to the power 9. So binomial expansion, we're going to get 9c0, 2 to the 9, plus 9c1, 2 to the 8, minus x over 16, plus 9c2, 2 to the 7, minus x over 16 squared. And that's all we need. We just need 3 terms. Find the first 3 terms in ascending powers of x. 1, 2, 3. Make sure you remember the minus sign needs to go inside the brackets as well, and over 16 as well. And just check all your powers should add up to 9. 9 plus nothing is 9. 8 plus 1 is 9. 7 plus 2 is 9. Cool. So once you've got that, you've actually got most of the method marks. Now we just do it, evaluate what all this stuff is. 9c0 is 1. 2 to the power 9 is 512. 9c1 is 9. So we can do all this in the calculator. 9 times 2 to the power 8. Massive. Divide it by 16. 144. Need a minus sign too. So minus 144x. And last one, again, calculator, 9c2 times by 2 to the power 7 divided by 16, which needs to be squared. 18. And minus squared is still minus. X squared is x squared. So we've got plus 18 x squared. That's your answer. So be careful with negatives, basically, with this one. Okay, part B, which people struggled with. We got to times the thing we just expanded by this, and we're told that the first 2 terms are this and this. Cool, so we're going to do this thing, expand it, get the first 2 terms, set them equal to this, and set the second one equal to this, solve them simultaneously to find A and B. So, A plus BX, 512 minus 144 plus 18x squared, which we aren't going to need. Oop, forgot an x. If we multiply these out, find the first few terms. So the first term is going to be A times 512. Then we're going to get A times 144. What am I doing? So I've done this. Now I'm going to do A times 144x, so we get minus 144 AX, and then we're going to do BX times 512, so plus 512 BX. Any more than that, and we're going to start getting squared terms. So we don't need to expand anymore. That's our expansion. This is the first term, and this would be the second term because it's the x term. So this term I can set equal to 128, and then this bit is all going to be set equal to 36. Just realised I've done this video portrait over. So 512a equals 128. That's our first equation. Next equation is that the second term, 36x, should equal all of this rubbish. So minus 144ax plus 512bx. So we've got to solve these two things together. So I can find a pretty quickly from here. So 128 divided by 512 gives us a. So a is a quarter. Put this a in here and find out what b is. So 144 times a quarter is the first thing we need to do. There we go. So 144 times a quarter is 36. So we get 36x is minus 36x plus 512bx. Add this onto the other side, so we get 72x equals 512 times bx. Divide both sides by 72x, and we get... Actually, let's do that better. Divide both sides by 512 and we'll get b equals... So 72 divided by 512, we get b equals 9 over 64. So those are our two solutions. Right, well next, question 9. Yeah, log to linear form. So these, you need to learn these because they're bound to come up in the exam. All we're going to be doing is logging this equation, which will describe this line, finding the y-intercept and the gradient, comparing them, and then using it to find a and b, and then interpret some stuff and make a prediction. So, starting off with our equation. So v equals pq to the power t. So I'm going to log everything. The reason I know we need to do that is because this graph is log v. This is an equation that says v. So if I log both sides, log v equals log pq to the power t. So just log both sides. Then we're going to split this up using log rules. So log v equals log p plus log q to the power t. So multiplication rule. Now I'm going to use the power rule to bring this power down the front. So log v equals log p plus t log q. So that describes this. Right, now let's have a read through. So we got the equation of the line. So they've told us the equation of this is equal to this. So this makes our job very, very easy. All we need to do is compare this equation to this equation. So you can see just looking at it, here's t. The bit times t is log q. The bit times t is 0.05. So I'm going to say log q equals 0.05. Good. Now we can say log p, which is the intercept, is going to be equal to 4.8. So log p equals 4.8. What we mean by log, remember, is log base 10. It's kind of literally an unwritten rule that log means log base 10. So if we want to find q, we can do 10 to the power this to get q and 10 to the power this to get p. So 10 to the 0.05 equals q and 10 to the 4.8 equals p. So calculator out. 10 power 0.05, oops, 10 to the power So q equals, what in decimal places? 4 sig figs. 1.122, there's q. And p is going to be 10 to the power 4.8. So p equals 63095. We want 4 sig figs, 1, 2, 3, 4. So this is going to get rounded. So it becomes 63100. So if you've got that wrong, go over what a significant figure actually means. Okay, next bit's pretty easy. Find the reference and we'll interpret p. So p, if we remind ourselves, was this thing, which is the y-intercept. And this is a graph showing us the number of years since a painting was recorded. So it's the value of a painting. of a rare painting according to time. So this is the value of the painting when it was new, or when it was first recorded. So we can say it's the value of the painting in Jan 1980. Or initially, they will probably get away with that as well. Let's have a look. Yeah, value of the painting on, for let's be specific, on the 1st of January 1980. Okay, part 2, find the constant Q. Well, Q was to do with our gradient. Okay, so we're trying to find out the value of, or reference what constant Q actually meant. So we found out that Q was our gradient. So let's read back through the question and decide what the gradient actually means. Remember, gradient is the rate of change of y with respect to x. So it's how whatever this is changes with respect to this. So if you read through, it's going to be the rate of change of the value. So how quickly the value changes with respect to the number of years since. So we can say it's the proportional, because it's a gradient, proportional increase in value each year. So proportion, gradient, increase in value because we're increasing our log v each year because t is measured in number of years. Cool, right, last bit to this, part C. Find the value of the painting as predicted by the model on the 1st of January 2010. Okay, so we're going to use our equation from the beginning. So v equals pq to the power t. P was 63100, so v equals 63100. Put q in 1.122 to the power of t. So all we need to do is work out what t is in this equation so that we can work out the value. So if we look through this, we're looking for January 1st, 2010. 1980 was the original, so we are looking at 30 years later. So we're going to put in t equals 30. Type it into calculator and we've got our value. So we get a value as this. So v equals 1994412.865 pounds. Okay, looking back through those, once more specifically, give your answer to the nearest £100,000. So if we go through this looking for hundreds of thousands, the nearest £100,000, we're on 990, so we're going to round up to another 100,000, which will put us at 2 million. Which is our answer. You need to have a pound sign there to get the answer though. Next one was question 10, which is about circles. First bit of this, very easy, most of you got the marks. Second bit of this, quite difficult. So first bit, we just need to find the coordinates of the centre and the radius, both of which we can find by completing the square on this. So I'm going to get my x's together, my y's together, and then complete the square. X squared plus x squared minus 6x plus y squared plus 10y plus 9 equals 0. So complete the square on x to get x minus 3 squared minus 3 squared, which is 9, plus y plus 5 squared minus 5 squared, which is 29, 25, plus 9 equals 0. Get all the numbers on the other side. And that's going to be equal to 25, take 9 plus 9, 25. So our centre is 3 minus 5, because the signs have to be different because it's inside the function. And our radius is the square root of 25, which is 5. So 3 marks for that. Next bit, find the range of values for k. So we're told that a line with an equation y equals kx cuts our circle at 2 distinct points. So if I draw what's going on, roughly, we've got a circle, the centre 3 minus 5, and it's got a radius of 5. So it's going to look something like something like that, very badly drawn. And we've got this line y equals kx. Well, kx will go through the center. So it's going to be one of these lines, depending on our gradient. And we need to find the range of k values, the range of gradients, that will let this line cut the circle at 2 distinct points. So anywhere between those 2 values, really. So the way we're going to do that is if they cut in 2 places, it means if you solve the equation of the line and the equation of the circle simultaneously, you should find 2 points of intersection. 2 points of intersection means the quadratic that you'll get that gives you these 2 points should have 2 solutions. In other words, its discriminant should be greater than 0. So if we put these together, try and solve them simultaneously, and then find the discriminant of that, set it to greater than 0, we can find what the range of k values are that will make all that happen. So x squared plus, which are y is kx, let's put kx straight into there. Minus 6x plus 10 lots of y is kx, plus 9 equals 0. Alternatively, you could have put kx into your completed square version here, and you'd get exactly the same thing once you've done all the expanding. So if we expand this, x squared plus k squared x squared minus 6x plus 10 kx plus 9 equals 0. So the hard bit now is deciding what is a, what is b, what is c for use of the discriminant. So we get all the x squareds together, but we can't have 2 x squared terms. So we need to factorize this. So we just have 1 term for x squared, 1 term for x, and 1 term for whatever numbers are left at the end. So take out x squared as a factor, and we get 1 plus k. Take out positive x as a factor, and we get 10k minus 6. So it basically factorized x out of here, x squared out of here, and got these 2 factors, plus 9 equals 0. So when we're doing the discriminant, b squared minus 4ac is greater than 0. Those are the values we need to use for a, b, and c. So a, b, and c. Once we've identified those, we're going to say b squared minus 4ac is greater than 0 because 2 roots slash solutions. We're going to square that, put it all together. So 10k minus 6 squared minus 4 lots of 1 plus k times 9 should be greater than 0. So we get 100k squared minus 120k plus 36 minus 4, sorry, not minus 4, minus 36 minus 36k should be greater than 0. So plus 36 and, sorry, those, plus 36 and minus 36, those are going to cancel out. So we're left with this quadratic to solve, so 100k squared minus 156k should be greater than 0. And we can either solve that in a calculator or basically sketch it and find the roots. So one of these roots is going to be at 0. The other root is going to be at 15 over 8. So we want, when is this graph, when is this function greater than 0? Well, this bit's greater than 0 and this bit's greater than 0. So it tells me k has to be greater than 15 over 8 or k has to be less than 0. When those values are true, for this line, it will cross the circle in 2 places. So if the gradient is less than 0, if the gradient is negative, you'll always do it straight away. If the gradient is more than 15 over 8, so steeper than 15 over 8, you'll do it, or always negative. Cool. So last question from paper 1 was the area integration question, which is always a favourite of students. So this one's pretty vague. It's a 10-mark question. There's no parts to it, so we need to work out exactly what it is and have a thorough plan of how to find this. So we've got, if we zoom in a bit here actually, we've got then a quadratic meeting a line, and we're trying to find the area underneath both of them. We're told point P, so that's 4, 6, which is there. And we're told this line is a normal to this curve. So normal, if you remember, it means gradient is the negative reciprocal of the tangent gradient. So normal means the gradient of the normal is the negative reciprocal of the tangent's gradient. So we've got to do some differentiation first. Basically, if we can find out the gradient of this line, we can find out the equation of this line, then we can find where this line meets the x-axis, and then we can use that to find this area. So step 1 is just find this line and find where it meets the x-axis. So to find the gradient of the tangent, we're going to have to differentiate this curve. So you can see it becomes quite complicated. So the first step is going to be to find the gradient of this curve, which will be the gradient of the tangent to this curve, by using differentiation. So y equals 32 over x squared plus 3x minus 8. To differentiate this, I first need to bring the x squared up to the top. So we can say y equals 32x squared plus 3x, take 8. Now we're ready to differentiate this. So dy by dx, 64x plus 3. And we want to find the gradient of this curve at this point. So I'm going to substitute in x equals 4. Sorry, I completely mucked that up. X to the minus 2 there. So times it, minus 64, x to the minus 3. So we get 64 minus 64 lots of 4 to the power minus 3. Plus 3. Be careful with your minus signs, I just made a mistake. So this will turn into minus 64 over 4 cubed is also going to be 64 plus 3. So our gradient is going to be minus 1 plus 3, which is 2. So 2 is the tangent gradient. Okay, we don't need tangent gradient, we need the normal gradient because this is perpendicular to our curve. So our normal gradient is minus a half. So now we've got a gradient, we've got our point, we can find the equation of this line and find where it hits the x-axis. So equation of normal is going to be y minus 6 equals minus a half x take 4. Now, because we don't really care about the equation of the line, the whole point of doing this was so that we could find this point. And this is a point on the x-axis where y equals 0. So if I straight away just put 0 in here, I can solve this a bit quicker, and we can get straight to the coordinate of this point. So 0 minus 6 is minus a half x plus 2. 0 just doesn't matter. We can add half x to this side and add 6 to this side. So we get half x, or x over 2, equals 6 plus 2 equals 8. So therefore x equals 16. So the coordinate up here is 16. Right, once we've got that, we're now in a position to start thinking about how we're going to find this area. Now, with these questions, it's always a case of you need an integral area and the area of a basic shape, trapezium, rectangle, square, or as in this case, a triangle. So if I just drop down, the reason we got given this point P is because it's going to be important to finding this area. If I drop this down, we know that 4 there is going to be there on the x-axis. So now it becomes a bit clearer. We've got an integral here, and we've got an area of a triangle here. So if you find those two, add them together, we've got our area. Remember, the key here is integration finds the area between the curve, the x-axis, and whatever you decide are the two limits. So I always do these with shapes. So we're going to say weird little integral shape plus our triangle equals the thing we're trying to find. This bit is going to be from an integral between 2 and 4. And this bit is going to be just the area of a triangle with a base of 12 and a height of 6. So length of 6 there. So that's my plan. We can find this quite quickly and quite easily, so we'll leave that to later. Next bit, let's find this integral. So back to our original function, because that was our y function. We get y equals 32 x to the minus 2 plus 3x minus 8. And we're going to integrate that between 2 and 4. So 32 x to the minus 2 plus 3x minus 8 dx. Cool. So remember, integration, increase the power and then divide by the new power. So our power is going to become minus 1. 32 divided by minus 1 is minus 32. Plus x is going to go up to x squared. Divide by that, 3 over 2x squared. Then 8 is going to increase in power of x to 8x. Don't need plus c because we've got limits. So to put limits in, square brackets around your integral, put in your 2 and 4 limits. You're going to evaluate 4 first, subtract, putting 2 in. So minus 32, 4 to the minus 1, plus 3 over 2, 4 squared, minus 8 lots of 4. That's my first limit. Subtract my second limit. Space. So subtract my second limit. Minus 32 lots of 2 to the minus 1. Plus 3 over 2 lots of 2 squared minus 8 lots of 2. So there is my integral. Okay, so if we evaluate this, we're going to get minus 32 over 4 plus 3 over 2 times 16 minus 8 times 4, which is going to be 32. Minus 32 over 2 plus 3 over 2 times 4 minus 16. There we go. And if we work out all of that, we're going to get, I think it was 10, wasn't it? Yeah. So integral gives me an answer of 10. Cool. All I need to do now then is find the area of the triangle and add it to the 10 I just found, and we've got our entire area. So triangle, if we go back to my little sketch, 6, 4, so, 6 and 12, so 6 times 12 times half base times height, which gives us an area of 36. So we got 10 plus 36, giving us a total area of 46. Cool. Right, that's it for paper 1. I'll do a second video for paper